Hello everyone, my name is Master Elena. I'm from the Department of Environmental Sciences and Policy, and today I'm going to present my IGDV project to you. Topic of my project is observation of vegetation cover and vegetation cover changes of the Great Green Wall of Africa initiative. Let's start. First of all, deforestation issue or desertification issue is very important issue of modern society. Desertification is a type of land degradation that happen in dry land, that means in arid or sub-arid areas, that is being showed by the loss of biological productivity and trees losses due to natural process of land degradation or due to induced human activities in these areas. And due to global climate change and temperature growth, it's become even more significant issues nowadays. And the Great Green Wall of Africa, or the Great Green Wall on the Sahara and the Sahel region, is Africa's flagship initiative to combat the increasing desertification. This initiative is led by the African Union's countries. That means 21 countries participate in this project implementation, and the initiative also aims to transform not only the drylands and soils, but also to transform and to improve the lives of millions of people who live in these areas by creating a mosaic of green and productive landscapes. It's not just about planting trees, but also about social and ecological resilience in these areas. The initiative brings together more than 20 countries, as I said, and also majority of regional and international partners, such as UNEP, Food and Agriculture Organization, Global Environmental Facility, and the World Bank. The main goal of the project is to convene a partnership that supports local communities towards working on sustainable management and the use of forests and other natural resources. This project is mainly aimed at planting trees, but planting not just monoculture, but different kinds of trees on different areas, just according to specification of every environmental and background and ecological systems, and also according to social needs of the certain societies. But the question that I asked and that I tried to answer during the working on my project is, did the project implementation result in significant vegetation cover increase? Because we know that this project is being in the process and everything is being implemented and it's continuous nowadays, because it's just only 15 years passed from the start of the project implementation. So we need to see how vegetation changed during these years. And for answering this question, I choose NDVI index as a main indicator. NDVI index is just normalized difference vegetation index that's commonly used to see the difference between vegetation growth and losses on the area. And here you can see that I uses NOAA dataset for my project because this dataset of NDVI from National Centers for Environmental Information is quite reliable, and everybody uses over the world. So let's see how I just visualized the data. First of all, I just used Google Earth Engine to download the data, and I tried to use data for this year, for 2020, but data for 2020 isn't sufficient. It's still being under construction. So I just used the data from 2007 till 2019. So, and first of all, I just uploaded this data. Here you can see the process that I've done through. And I downloaded this range of years. 207, 9, 11, 13, 15, 17, and 19. I decided not to download all the data, just year by year. And I just downloaded all the data from roughly the same period of time. For me, it was just the beginning of every year. It's like January 1st, just to show, just to make my project and results more valuable and reliable to comparison. And then I just downloaded the data and uploaded them into QGIS and did some basic dataset review. Here you can see that I just used some layer properties, stylization, symbology, and I set this color ramp to see the differences in NDVI indexes. From green, that means maximum, that means like positive changes, to red, that means like negative changes in the NDVI. Then I just received this visualized picture of NDVI indexes. Here we can see the area of Africa, this Sahel region. And I just did the same with all data set that I downloaded from 2007 to 2019. After that, I did a raster calculation using a raster calculator because I need to calculate NDVI differences between some years. So I just calculated and received three data sets, the differences between 2007 and 11, between 2011 and 15, and between 2015 to 2019. So like every data set represents 4 years differences. Then I just received some data sets, and I just simply decided not to put negative changes of NDVI. So I just decided to show only positive changes. So here the value is just valued from minimum 0 to possible maximum. And I just input like no change, no increase, low increase, medium increase, and high increase in NDVI in these data sets. So here we see roughly what I got through this stylization process. It's an image again of Sahel region, and I chose this color ramp, but I will change it after. But here on this picture also I show how just I actually implement all this technique to every data sets that I got through raster calculation. The next, I did some georeferencing, because we need to reference the data. We need to show the borders of the project and all the participants on the map. So first of all, I just downloaded countries borders here. Here you can see just my data and countries borders. Then I just added the cities and populated sites, populated areas. And after that, I just found a picture that shows the Great Green Wall Initiative project. And now I need to do a georeferencing. So I just gone through georeferencing process. Here you can show how I did it. I just actually use a georeferencer in QGIS, and because African's borders are really good for do georeferencing, and it's so easy to do. And here is the results of my georeferenced, it's referenced image. And after that, I just simply create two vectors layer. One of them is participants. It's a little bit, this red line shows this project's participants, few countries. It's not so obvious now, but I will continue to work on it later. And also I just drew a line of focus area of the project. Now we can work with this focus area, participants, with borders, and also with NDVI changes themselves. So here you can see how I simply changed all the visualization, all the map. I simply added some countries' names. I changed the stylization, so now we can see the better results, the best way to see this data and these results. Here, like red dots, borders, such as participants. Yellow one is focus area of the project, and green one, like this greenies, I changed the color ramp of NDVI changes. So the greener means like NDVI is higher on this area. NDVI changes is more significant on these areas. So, but our focus area in this orange one. So let's see. This image, exactly this, shows changes between 2011 and 2007. So we can see like quite significant changes here in Nigeria, Burkina Faso, Senegal area, and also some, but not so significant changes in Eritrea and Ethiopia. But now we can see how it changed from 2011 to 2015. So now we see a lot of significant changes from 2011 to 2015 at Burkina Faso area again, let's see, but more significant. Almost no changes at Nigeria. See, not so significant in Senegal, Gambia, Guinea-Bissau, but really, really significant challenges in Ethiopia and Eritrea area. After that, I also made a comparison between 2015 and 2019's NDVI changes. So this was like, we already knew this data, it's just the changes between 2015 and 11, it's just the NDVI growth during these 4 years. And this is what happened during the next periods of time between 2015 and 2019. We simply almost, we don't see any big changes here, but probably only on Senegal and Mauritania's areas, somewhere in Nigeria and Chad. But that just means it just represents only NDVI changes. It doesn't mean that nothing happened or the forest died, because it just changes on NDVI indexes. So also, I just asked myself, is there a correlation between NDVI changes, like positive changes, and only small populated sites? Because the main idea of the project, as I said, it is not just to plant the trees, but also to maintain and to improve social resiliences. So a lot of project areas is simply just connected to local communities areas. So that's why I used populated places dataset here, but chose only very small areas, like cities and populated sites with very small areas, from even 0 to 20 square kilometers. Here we can see the dots of this map. So this is this data set is just from the changes on between 2007 and 11. This is changes from 2011 to 2015, and these changes is from 2015 to 2019. It's just these 3 data set that I showed you before. And I let me just go up, and here I can see the barely correlation with changes. On the second data set, like the same, like really weak correlation with populated sites and NDVI changes. But on the last side, I didn't see any correlation. So for me, that means that probably the using of this correlation and this trial to find this correlation is not so successful. So discussions of my findings is like that I actually just made 3 proposals. First of them is we need to narrow down the research scale, because as I said, it's mosaic project and we cannot simply use this technique to see the changes on these large areas. The second one is that probably it's not a NDVI technique and methods, it's not the good one. Probably it doesn't show the good results, and it doesn't reflect the results of this project. And the third one, probably these changes in NDVI rate in vegetation cover, it just simply not due to successful implementation of your project, but due to differences and changes at precipitation level, temperature change, etc. And thank you for your attention. I hope that you found my results quite interesting. And if you have some questions, just you can email me by my CU's mail. Thank you.